Hello there. So good day. Today we'll be talking about piezo buzzers. So in our laboratory, we'll be doing interfacing piezo buzzers with Arduino Uno board. So for an introduction, a piezoelectric speaker is a loudspeaker that uses the piezoelectric effect for generating sound. So when we say piezoelectric effect, it is the ability of certain materials to generate an electric charge in response to applied mechanical stress. So the initial mechanical motion is created by applying a voltage to a piezoelectric material. And this motion is typically converted into audible sound using diaphragms and resonators. Compared to other speaker designs, piezoelectric speakers are relatively easy to drive. Like for instance, they can be connected directly to TTL outputs, although more complex drivers can give greater sound intensity. So in this laboratory, we'll be doing something like, to make this entertaining, we'll be doing something like playing a song or simply playing a note like Do, Re, Mi, Fa, Sol, La, Ti, Do, like that. Or yeah, for a song, we'll be doing something like a Twinkle, Twinkle, Little Star. So yeah, things like that. So without further ado, before that, the specifications of the piezoelectric speaker, that a piezoelectric buzzer rather, that we'll be using is as shown. Okay, so without further ado, let's proceed to our program 1 with the title Play Me a Song. So we have 5 objectives here. The first one is obviously to create a song. We need to write an Arduino sketch to play the song that ensures that the song contains a minimum of 30 music notes. The second one is to design a light display. We need to use 8 LED lights to create a running light display after the song finishes, and implement blinking lights patterns during the song for added visual effect. The third one is to play the song again, but at a faster rate for at 75% to 80% of its original duration. Follow the faster song with another running light display, which is obviously faster as well. Uh, the next objective is for visual representation. We need to draw the schematic of the circuit using Tinkercad or freezing software or whatever software is available for you to use. And for the last is verification. We need to run the program and verify that it works properly, ensuring that both the song and the light displays functions as expected. So without further ado, let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board here, the breadboard, the LEDs, we have 8 LEDs, and obviously the resistors, and the most important one is the piezo buzzer. So let's take a look at our program code. So this will be our program code. So at the top, we have the constant declaration or the pin declaration. We have the buzzer pin, which specifies the pin number connected to the buzzer. We have the LED pins, which is an array containing the pin numbers for the 8 LEDs that we have. We have the note C to note B, which is the constant for the frequencies of the notes in our song, which will be Twinkle, Twinkle, Little Star. We have the constant melody, which will be the array of notes representing the melody, the name itself. And we have the note durations, which is the array corresponding to each note in the melody, where 4 represents a quarter note and 2 represents the half note. So we have the set of function, which configures the buzzer pin as output pin, and we have the for loop in the set of function. This configures each LED pin as output and calculates the number of elements in the LED pin array. So after that, we have the void loop. So in our void loop, we have the for loop that has a repetition. So this plays the melody twice. And the second time the melody is played is 75% faster, which we use a speed multiplier as a name. And we have the if repetition equals 0, which corresponds to that after the first playthrough, it executes a running light effects and wait for 2 seconds. And we have the while true, which obviously it stops the loops from running again by entering an infinite loop rather. And after that, we have the void play melody with lights. So here we have another for loop, which iterates the over each note in the melody. So we have the note duration as well. So this note duration calculates the duration of the note in milliseconds, adjusted by the speed multiplier. We have the tone. We have the tone here, which places the note on the buzzer. We have the LED index, which determines which LED to light up. It uses I modulus 8 to cycle through the 8 LEDs. We have the digital write, uh, which it turns on the corresponding LED high. So it just turns on the LED. That's what it does. So we have the pause between notes, which obviously pause, as the name it says, which waits for the pause duration. And digital write again for LED pins. And no tone buzzer pin, which turns off the LED and stops the buzzer after the note is played. We have the running light effect here. This, so this running light effect iterates from the first to the last LED, turning each one on for 100 milliseconds or zero point 0.1 second, and then turns it low. And we have the backward running light. So this iterates from the second to last LED back to the first LED, turning each one on for 100 milliseconds and then turns it off. 100 milliseconds or zero point 0.1 seconds. So let's try simulating the our program to see if we are really satisfying the objectives or the conditions correctly or properly. So let's start simulation. And there you go. As you can see, we've satisfied the condition. We played the Twinkle Twinkle Little Star. On the first time, it is in normal duration or normal timing. And after the second time, it sped up from the normal duration to a 0.75 faster or 75% faster. So that is all for our program 1. So let's proceed to our program 2, entitled Arduino Jukebox. So for this program, we need to create and design a musical jukebox, a menu-driven system running on serial monitor screen, comprising of 6 preschool rhyme songs or any 6 songs of our choice. So the user can select a song to be played with, or 1 to 6. And we need again to provide a running light pattern for each song, and it will be played as accompanied to the song that is being played. So for our Arduino jukebox, the songs that we are playing will be, first we have the Twinkle Twinkle Little Star. For the second song, we have the Baba Black Sheep, have you any wool? For the third song, we have the London Bridge is falling down. And for the fourth song, we have the 5 little ducks went out one day. And for the fifth song, we have the If you're happy and you know it, clap your hands. And for our sixth song, our last song, we have the Rain, rain, go away, come again. So that will be the songs that we'll be playing in our Arduino jukebox. So let's proceed to our Tinkercad. So as you can see, we've already placed the components. And if you've noticed, the components or the configurations are just the same like the previous program or the program 1. Why? Because we have the same goal here. We'll be playing a song. The only difference here will be the program code because we have a different objective. We'll be playing 6 songs. So let's take a look at our program code. So as you can see, we have the variable declarations here, which is just the same as the previous program, the buzzer pin and the LED pins. The addition here is the const int note. And this section or these lines define the constants for various musical notes like the C4, D4, and their corresponding frequencies in hertz. 262 hertz, 494 hertz, etc. The next line is that const int twink melody, the const int ba melody, or the const int for 6 songs. So basically, this section defines array for different songs, and this stores the sequence of musical notes for a particular song using the note constant defined earlier. This, as you can see, we have the note C4, note 4F, etc. And we have the twinkle durations here. The twinkle duration, bar duration. So these are basically durations that so this array holds the durations in bits for each note in the corresponding song melody. Now let's move to our setup function. So we have the pin mode. So just the same as the program 1. We have the buzzer pin set as output. We have the pin mode for LED pins set as output. And the serial begin, this is the addition because we'll be using the serial monitor. So we have the void loop here, which says choose song. So this choose song is a function which prompts the user to select a song via the serial communication and place the chosen song. So we have the void choose song. We have the serial print line here, which says pick your song. This will be shown in the serial monitor as the moment you open it. We have the while loop that waits until there's data available for the serial communication. We have the switch. So this switch statement checks the chosen number. We have cases 1 to 6. So basically, this corresponds to playing the melodies and durations stored in the respective song arrays using the play melody with lights. This, and the default, which case, which handles invalid song selections. We have this void play melody with lights. So this function plays a song melody with flashing LEDs. So the for loop iterates through the entire song. We have the int duration here, int note duration, which calculates the duration in milliseconds. We have the 1000 milliseconds or 1 second for the current note based on the corresponding value in the note duration array. So we have the tone. We have the int LED index. So this calculates the index for the LED that will light up based on the current note position. We have the in pause between notes, which is so these are just a repetition of the same program or the program 1. So let's skip those. And here we have the void running light effect. So this function creates a running light effect with LEDs, as simple as that. And we have a delay of 100 seconds, same with the program 1, 100 milliseconds rather, or 0.1 second. So let's start the simulation to see if we're really accomplishing the objectives or the functionalities properly. Oh wait, we haven't shown the serial monitor yet. So there you go, as mentioned, the pick your song print line is shown as the moment I open the serial monitor. And let's play song number 1, which is Twinkle Twinkle Little Star. So listen carefully. And there you go, we have the song number 1, the Twinkle Twinkle Little Star. Now for song 2, we have the Baba Black Sheep. So there you go, for our song number 3. So for our song number 4, the 5 Little Ducks. For our song number 5, and for song number 6, so there you go. So let's proceed to our program 3, Arduino Piano. So our objective or task for this program is to connect 8 button switches that represents the notes Do, Re, Mi, Fa, Sol, La, Ti, Do. And the program should allow user to play a song through the button switches and buzzers which are connected to the Arduino board. So we need to write a program to simulate a piano and run that program to verify that it works properly. So without further ado, let's take a look at our Tinkercad. Well, let's proceed to our Tinkercad. And as you can see, we've already placed the components. We have the Arduino board, the breadboard, resistor, the piezo buzzer, and the button switches that will represent Do, Re, Mi, Fa, Sol, La, Ti, Do. So these button switches are connected, is one part is connected to the ground, and the other port or the other, to the other port or the other part is connected to the resistor, which is connected to our pins, and the Arduino pins. We have the buzzers here connected to the pin 2 and its negative output or negative pin. So let's take a look at our program code. So as you can see, we have the variable declaration at top. Similar to the previous program, we have the buzzer pin at pin 2, and we have the const int button pins. We have 3 to 10. This creates an array named button pins that holds the pin number 3 to 10 connected to the buttons. And similar to the previous code as well, we have the const int do, re, mi, fa, sol, la, ti, do, and its corresponding hertz. We have the setup function here, which runs once when the Arduino is powered. And we have a pin that is set as output, which is the buzzer pin or the pin 2. And we have the for loop here, which iterates from 0 to 7 because less than 8. Setting each button pins 3 to 10 as input pins with internal pull-up resistor using pin mode button pins I input pull-up. Pull-up resistors ensure that the buttons register a high value when not pressed rather, or connected to the ground. We have the loop function here. So this function runs repeatedly after the setup function finishes. The loop body checks each button 3 to 10. We have 3 to 10. And if a button is pressed, we have the digital reads here. So if a button is pressed, it reads a low value, or this is due to the pull-up resistor, and it plays the corresponding musical note on the buzzer using the tone function for 200 milliseconds or 0.2 seconds. So the function iterates through the buttons checking for presses. So we have the 3 to 10 or 10 to 3 corresponding to the button pins, which are connected to the Arduino pin 3 to 10. So let's simulate our program code to see if we're really satisfying the conditions. So let's start simulation. So let's first click this button. So as you've heard, it plays do, re, fa, so, la, ti, and do. So let's play it consecutively. So there you go. So as you've heard, and as you can see, we've satisfied the condition for our task for our program 3, the do, re, mi, fa, sol, la, ti, do. So that is all for our program 3. Thank you. So let's proceed to our program 4, the switch controlled siren running light effects. So for this program, we need to connect 3 red color LEDs with 3 limiting resistors, another 3 yellow colored LEDs with 3 limiting resistors as well, and another 3 blue colored LEDs with 3 limiting resistors to our Arduino board via the breadboard. So we need to write a program to make a switch color siren player, which will be controlled by 5 toggle switch or tactile push button switch. We need to provide 5 different siren tones that will be controlled by the switches. So each tone should be accompanied by the different running light patterns. And obviously, we need to run the program and verify that it works properly. So without further ado, let's take a look at our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, another breadboard, a small breadboard, the resistors, the piezo buzzer, and the 3 red LEDs, 3 yellow LED, and 3 blue LEDs, as well as the 5 push buttons that will be used to play the siren or the different sirens. So let's take a look at our program code. So as same as before or same as the previous programs, you have the buzzer pin at pin 2. We have the button pins at pin 3 to 7, as you can see here, pins 3 to 7. And we have the LED pins at pin 8 to 13 and A0, A1, A2, which are the analog pins. So we have 8 here and the analogs here. And we have the function prototypes. So this line declares the functions that will be defined later in the code. The void play siren 1, which corresponds to the first siren sound, and the siren 2, second siren sound, etc. So similar to the functions, we have the running lights function declared here. And we have the setup function. So similar to the previous code, we have the initialization for the buzzer as output, and the button pins as input for the pull up because of the pull up resistors. We have the serial begin here for the serial monitor. So for our loop function, so this outer loop or the for loop, this iterates through the buttons pin 0 until less than 5 or until pin 4. We have the if statement. So this checks if the current button is pressed low. So this is due to the pull-up resistor. That's why this is set as low. And we have the if the button is pressed, then a switch statement is followed. This switch statement has 4 cases. And this identifies the pressed button based on its index, 0 to 4. And calls the corresponding siren function, the play siren 1, 2, 3, until 5. So, we have here the siren function. For the play siren 1, this plays the police siren sound. And for the play siren 2, we have the ambulance. The 3, we have the fire truck. 4, we have the air raid siren. And the 5 is just a custom siren. So, these sirens, the play siren 1 to play siren 5, has a similarity of having no tone buzzer pin. So, this stop the sound at the end. So, for the place siren 1, the police siren. So this alternate between two tones, only two tones, with a flashing light of with a delay of 250 milliseconds or 0.25 seconds. So for the siren 2, for our ambulance siren, this is similar to the police sirens but with reverse tones. So as you can see, we have here the 660 and 880 for the police siren, while on the ambulance sirens, we have the 881st before the 660. For the police siren 3, we have the fire truck siren. So this in this fire truck siren, this sweeps a range of frequencies up and down with fast flashing lights. As you can see, we have the two for loops here. The up from 440 to 880 and the down for 880 to 440. And for our play siren 4, for the air raid siren, so this sweeps frequencies up and down with varying light flash duration. So similar to play siren 3, we are also using the 440 to frequencies to 880, 880 to 440, and with a delay of 50 milliseconds. Same with uh no rather we have the lights at 10 milliseconds for going up frequencies and 50 milliseconds for the going down frequencies. So we have the void play siren 5, the custom siren. So this custom siren alternates between two tones as well, but with slower flashing lights. As you can see, we have the 500 milliseconds or zero point 0.5 seconds. So at the end, or for our last function, we have the void run light. So this void run lights, this is for the flashing light effect of all LEDs. So it uses a two nested loop. We have the four loop with a durations of 18, and then turns them off. So the outer loop, this creates an iteration for 0 to 8 pins because less than 9. And for the inner loop, we have the Z7 to 1 because greater than 0. And again, the duration is 18, which divides the provided duration by 18 to control the speed of the flashing light. So that is all for our program code. Now let's start the simulation to see or check if we're really accomplishing the task or the functionality of the program properly. So let's first play the siren 1. So as you've heard, it plays a police siren. So for our siren 2, this should play an ambulance siren. Now for our siren 3, the fire truck siren. For our siren 4, the air raid siren. And lastly, for our siren 5, which is the custom siren. And that is all for our functionality. And as you can see, and as you've heard, we played the sirens correctly or properly. The fully siren, the ambulance siren, the fire truck siren, the air raid siren, and the custom siren, and with their varying flashing lights.
Bro, malulobot nila.
So that is all for our program 4.
And that's all for our laboratory exercise number 5, interfacing a piezo buzzer on Arduino Uno. Thank you for watching!